And I'm live. That is cool. Today is 20th of August. Shit. Today is 20th of August 2025 and Wednesday. Shit. And we are going to solve some 1400 rated questions today. And let's see how it goes. Tomorrow we also have a contest which is going to be cool. Let's see. And I expect that I will reach a rating of 1400. That is, I will become a specialist in tomorrow's contest. And let's see how that goes. But before that, I have to solve some questions at 1400 rating. We did almost all of these questions. I, one is remaining here, and we have one remaining here. Then at 1200, we have 1, 2, 3 questions remaining, and at 1100, we did all of the questions. Now 1400. Let's go with stopwatch. And yesterday's stream on number theory was pretty cool. Yep, it was pretty cool. And now we know quite a few things about number theory, which is cool. Okay, no server. Linux set, attached, TCP, right? Make a new folder for 1400. I will go there. And here I will start my Vim and do the updates. And here also go into the folder, quit, and I will start my timer. I can put this thing up, problem solving mode. Okay, I will just start my timer and start doing the questions. And after I have solved a question, I will go through what I did in the question. Let's go. But this is 1400 and let's see. And this is going to be my first 1400. Let's go. Okay, that is cool. Sasha, oh no, N and M. Yes. Okay. Okay, cool. Okay. Sasha. Should. Correct. Okay, I want to get this right the first try and the first submit so I can make sure it is correct. I'm taking n and m. Then I'm incrementing m by 1 because m represents the number of zeros and the total number of digits would be number of zeros plus the 1 at the front, the most significant bit. Then I'm creating a vector which will store the number of zeros in individual digits whichever have zeros at the end. Yes, shit. Okay, okay, this is wrong. This is wrong. This is wrong. Yes. Yeah. Yes, 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 yes. Okay. Now we are now we should be good. Yep. Because the mistake here was that this thing would count a zero even if it is appearing in between a number, and I do not want that. So whenever I see that I didn't got a remainder of zero, I would say done equals true, and if done ever is true, then I will not increment my current zeros. That is the thing. Right, so everything else I'm seeing in CZ done false while C total number of not zeros total, yes, total for the total number of digits. Then winner a string, then sort the number of zeros from highest to lowest. Initially, what Anna will remove is Z minus 1, and yes, Anna has n moves, total n moves, and Sasha at most has n minus 1 moves at most. Not even at most, he only has n minus 1 moves. Because Anna goes first and she can make a move even if it is the last element remaining. And I also have to make sure that there are more zeros which Anna can use in her favor to reduce the total number of digits. And while my index is lower than the size of zeros, I will keep moving. And if at any point I see that the total number of zeros is lower than m, the total number of digits that would be required in the number for Sasha to win, if that happens, then winner is going to be Anna, and I break. Or I can simply break because I am testing the same thing here. Right. And then after that, yep. If that is not the case, I still have my total is still greater than m. Then I will remove the zeros. Anna will remove zeros from total, however, how many she can. And if I is lower than n minus 1, that is if this is not the last move. If this is not the last move, then Sasha can increment. Sasha can use one of the zeros so that he does not lose them. And then if total is this, then Anna wins. Otherwise, Sasha wins. And then see out the winner. Okay. Locally it runs. Yep. Okay, cool. Let's see. This is going to be cool if it works. Let's see how it goes. Zaki, hello bro. Sorry to disturb, but want resource you following. This is accepted. Shit, that is cool. That is cool. I'm happy with that. Okay, I am following. For questions, I have this thing, CP31 that I'm following. And this is for questions in general from code forces. But for specific questions, like for example, right now I am learning about graphs, then I would like to solve some problems on graphs. For that, there is this thing, CSES problem sets, and there you can go and practice stuff specifically. So graphs, range queries, dynamic programming, sorting, searching, introductory problems, everything. So that is cool. Hey, I solved this problem yesterday. What a coincidence. That is crazy coincidence. And I can remove this. So now I will explain what I did. And this is cool. This is cool. I got this. This is cool. And I can write 20 minutes in this thing because I would like to see how much time it will take me when I solve this later. And yep, going to Excel draw. So in this question, we have been given a list of numbers, let's say like this, and n is the number of numbers that we have, and this second number k, it is called k, it is denoted by k in the question. This number is okay. So before anything, you have this array and there are two players A and S. First it is A's move and then it is S's move, and what A can do, A can take any number from this and flip the number around. That is, she can make 10 into 0 1, which is simply 1. That is all she can do. And S can take two numbers, any two numbers, and concatenate them. Like this would become something like this. And shit, I am stupid. I didn't thought of a case. Yeah, this is cool. This is cool. Even though I didn't thought of a case that in this case, even though he is using two numbers which have zeros at the end, he is only able to save zeros of one number and not the other. But that was taken care of because I was only adding 1 0. So that is cool. Okay, so what S can do, he can choose any two numbers and concatenate them. And then the array would become something like 10 1 0 1 0 and 10. Now there are only three elements, and now A will choose one of the elements from this new array and flip them and do the same things. So now at the end, when there is only one element remaining in the whole array, we have to answer if that element, whatever it is, let's call it x, if x is greater than or equal to 10 power 5, in this case 10 power x. So the individual numbers don't actually matter. Like even if it was 2, 3, 4, it would not matter. The main thing that matters is the number of digits there are. So totally in the start, if let's say it was only S doing the operations, then S would be able to add all of these digits and would get 1 0 1 0 1 0 and 1 0. But we also have Anna, and she can flip some of these numbers, and she can, let's say, flips this one of the tens and it would become a 1. And the consequence of that is that from this ideal string we would lose one of the zeros, and if she does the same thing again, we would lose another 0. So what I am doing in my code, I have a total count which represents number of digits in this ideal string, and then I have a vector of zeros which would store in every digit, not in every digit, whichever digit has a leading zeros at the end, how many zeros there are. Because Anna, let's say she has two choices, either she chooses a number like this or a number like this, and she would like to choose a number like this which has a lot of zeros, because when she chooses this, this would become 1 and she would be successfully able to remove 3 digits from the ideal string. So that is cool, and that is going to be stored in this array. So after this, after is filling the array and taking the total count, I have to sort the number of zeros from beginning, from the biggest to the end, and in descending order. And then initially the 0 that Anna is going to remove is at index 0. And then I'm iterating because from 1 to n, because at most Anna can make n moves. Because even if n is 1, let's say we have a single digit, Anna is going to make one move, and on Sasha's move, he would notice that there is a single element and he cannot join two elements because there is only one element there. So the game ends there. Therefore, Anna can make n moves at max, and we will do this while there are some zeros to be removed. And if at any point we see that the total is lower than m, that is, we have already removed, Anna has already removed a lot of zeros, and the total number of digits is already lower than m, then we can break. Otherwise, if that is not the case, then we can remove the current number of zeros, the current maximum zeros that Anna can remove from the total. We can do that, and we can increment the index of zeros if we are already not at the last number. And this is not even necessary. And then here we are checking after the loop, if total is lower than m, then Anna 1. If it is not lower than m, if either it is equal to m or greater than m, then Sasha 1 and winner. We just print the winner. That is cool. Refresh, and this should become green, and it does. That is cool. Now we would move on to the next problem, which is cool. What about concepts, learning and all? For concepts, there is CPHB, no, CPHB, Competitive Programmers Handbook, this thing. And this is not a comprehensive guide because in yesterday's stream, we were going through number theory. And in this, we saw some pretty amazing things like this Euler's theorem and Fermat's theorem and this thing, why this thing works. And there was Euler's totient function. And this is surely not enough explanation to understand what this thing is and why this thing works. But the main goal for me in this book is that I can see that there is something called Euler's totient function, and then I can do my own research either on ChatGPT or read some article about this thing till I understand this thing. So this book acts as a index through which I can see what the topics important to competitive programming are, and then I can do my research. Because look at this thing. Here we have, more generally, Euler's theorem states that this, when x and y are primes, Fermat's theorem is just a special case of this theorem. And that is all this book says on Euler's theorem. But this is not enough explanation for it. But I know that there is something called Euler's theorem, and I can go from there and do my own research. To zoom in the page, I have a remap like this. Because my mouse has a few extra keys, I have used this thing, Mac mouse fix, and I can do these things with my mouse, and I can also change the windows with my mouse, which is cool. And cool. I would now go to the next question. But also, before going to the next question, I would like to see in the last one some tags. Okay, greedy, match, sorting. We did use sorting. And let's read the tutorial for this one. E in division 3. Good. We are getting closer to the last one. Anna and Valentine's gift. If the decimal representation of a number x has exactly c digits, then x greater than equal to 10 power c minus 1. From this, it can be concluded that Sasha is not required to maximize the final number. It is sufficient for him to maximize the number of digits in it. Yep. During his turn, Sasha does not change the total order of digits, but Anna can change it. Total number of digits, but Anna can change it. It is easy to understand that the total number of digits cannot be increased, but it can be decreased if Anna removes trailing zeros from something like this. Now, the optimal strategy for Sasha and Anna can be formulated. Anna should choose a number with the largest number of trailing zeros and remove them. Sasha should find a number with the largest number of trailing zeros and concatenate it with any other number. Thus, since 1 is lower than equal to AI, he will preserve the zeros of his number. Makes sense. Implementation implementing such a solution as n log n can be done using sorting and linear traversal using set. If desired, counting sort can be used to improve the asymptotic complexity to linear. Okay, and how do they implement this thing? Build. Okay, yes. Okay, I do not like this thing when they declare variables in the global scope and then use them inside. I really do not like this thing. Sort and reverse. Okay. Okay, you did sort and then reverse. You could have sorted in reverse. But anyways, len I. Hey, cool, I guess. Now we can move on to the next question, which is cool. This one, grouping increases. You don't need to understand something like Euler's toting function right now. You can learn it later when you come across a problem that uses it. I have rarely solved problems on Euler toting function. Yeah, I mean, I didn't understood I didn't do my research on Euler's toting function for the sake of understanding that specific function, but the act of it represents a thing that says I will do things which are hard, and yeah, it represents a mindset, and that is what I was chasing. Not specifically I want to learn the Euler's totient function. It represents a mindset, and that is what I was chasing with that. I wanted to prove to myself something that I can understand this thing, even though I might feel like I cannot. So that is cool. Now grouping increases. This is the next one. And I will go into the problem solving mode. Yep. And cool. Okay. Two subsequences. Shit. Okay. Okay. Two subsequences. Isn't this like longest decreasing subsequence? If I take that, output here is 3. Answer is 1, which does make sense if I take 8, 7, 4, 3. Or I could optionally choose 8, 3, 1, 1. Then also the answer would be 1. There are a few possible possibilities. Here I would like to remove this. No, if they are all increasing, if they are all decreasing, then this is fine. I do not want to remove. That is totally fine. Like this. Then I would like to remove this. Longest decreasing subsequence. Dynamic programming. Hello. Yes, I'm struggling right now a little bit. I think this whole thing is wrong, my implementation and my algorithm also. There are some numbers which are causing the problem, and it would be cool if I could just remove those numbers, and removing them either decreases the count, decreases the problem, or keeps it same. And in this case, here is the first pair where I have problem. 2 is smaller than 3. So I would like to remove this, then remove this. No, I would only remove this because this is the only thing that is giving me problem. And then I would check if the next thing is also giving me problem. It is not. So that is cool. I can move on here, here, and then I would see that here I am having problems. So I can remove this and put it in the other array, and cool. Okay, this works. And after I'm done with this whole thing, I can go to the other array that I created, or maybe, and count the number of, because here I know that everything is cool, right? No, that would not work. That would not work. I feel like here I have to use DP somehow. I might be very, very wrong, even though I am using DP. But the thing is, I do not need to find out those new arrays that I will create. I only need to find out the number of inversion in pairs, number of pairs in which the first element is smaller than the last element. And I cannot use a greedy algorithm because that will yield wrong answer for a case in which I have something like this. If I were to choose this as my subarray, and then if I see the third element, which is this, and in a greedy algorithm, I would like to remove this, then let's say everything is like this. So it would have been much better if I just removed this one in the first place. So I cannot use a greedy algorithm. Maximum. Okay, I have found out the length of the maximum reducing subsequence. Let's see if at least that works. Okay, what do I expect in this one? I expect to see 0. In this one, I expect to see 4. Here I would like here I would like to see 5, and here 1, and here 2. Let's see. It is not even running. Wait, okay, it does not output anything. See how Tmx. And it keeps on running. That is bad. Time limit exceeded. Makes sense. Makes sense. Okay, I do see 5. Shit, I have accidentally found the length of the longest increasing subsequence. Okay, which is wrong. I'm just returning the length. Wait, okay, okay. This thing should give me something. 1 is correct. 1 is correct. That is what I was hoping for here. And 3 is wrong here. 1811 is a correct answer. And even better than that, 8743 is also the longest increasing subsequence. I can put index. I can create a index array so that I would know the actual sequence which I am going with. Okay, lower bound, lower bound, AI, current maximum. Okay, 3 is clearly wrong. Okay, shit. Okay, okay. It is because of this. It should be 8. Not 8, but AI 0. Now I expect here instead of 3 to see 4. And let's see. And I do see 4. So that is correct at least. And now I can create a vector which will store the history of the elements which I have gone through. But this is not very optimal, and I think there should be a better solution. But this is what we are going with. Because this is the only solution that is coming to my head. And int mx I. We will start at 0. Index 0, iterator, lower bound. And I think this might even give me time limit exceeded error. History for I would be equal to, I do not know the index for this thing. I only know its value. I do not know the index. Yep, I do not know the index for this thing. That is bad. Shit. I only know its value, which is bad. Okay. 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 I also need to know its index. So I can create a vector of pairs. Okay, this is getting more complicated than it needs to be. Let's see if I can do this way. History is 0, 0. Yes. And whenever I see this, then history I dot first. No, I need it from the map, not from the history. I need it from the map. The index. Yep. So map has to change. Map has to change. I can use a pair. And this is way more complicated than it needs to be. But still, let's see if I can do this. Dot second gives me access to the pair, and there I want access to the first element. And here the same thing, and then in history vector of integers for I is going to be go to it dot second dot second, which stores the index, Okay, and if cmx greater than mx, then first of all mx equals cmx, and second mpa first cmx and mp ai dot second is going to store the index of index which is in history I. It is going to store the current index I, and yes, and mx I is also going to store the current index. And if that is not the case, first one dot second I, second is the index. Now I have a good state and I can trace back. This is very bad. This is very bad code. I do not even need the sequence. I only need a single integer which represents what I did. It has been 37 minutes. Okay, but I will get this done with this method. And we can see the more optimized and better approach in the tutorial in a while when I get done with this. Okay, after this, since now we have the state, what do we need? Since now we have the state of the path that leads us to the maximum decreasing sequence, we would like to construct an array without that path and calculate the number of increasing pairs in that new array and work with that. Okay. This is very bad, by the way. Okay, so since I have the path, how do I get the elements which are not in the path? I can store all of the indexes in a set of size n. That would be very, very bad. That would be actually very bad. No, I can store the path in a vector from the highest to the lowest index, and when I'm traversing through my original array, I will see if I am whether I am at a index whether I am at an index which has been removed, and if it has been removed, then I can skip. If it has not, then I will see if I can compare it with the last one. Makes sense, and it would be a bit more complicated to implement, but that is what we are going with. And right now, ACD, and right now, yes, the path. So let's just experiment. Okay. Uh, int I equals mxi, and while history of I is not equal to I, path dot pushback I, and I equals history of I. Okay, and at the end I will have my I variable left, and since I'm pushing back, so I would have to reverse bi-directional iterator, first and second, path dot begin and path dot end, and before this path dot push back I, because this is the first thing in the path, then reverse the path. And now for int or int x in path cout ax space, right, cout new line. This is not the correct answer, but I am trying to see if we can find the longest decreasing path, and we can. Yep, these are the longest decreasing paths, so that is good. And since we have that, all we have to do is now start iterating from the front. I equals 0, I less than n, I plus plus, and if current thing is not in the path, but that is bad, we would not like to do that. Instead of path being a vector, it would be very cool if it were a set, so that I can quickly, no, it is in decreasing order, so yeah, int p 0 while while I is not equal to path, the current, while I, okay, shit. It would be much better if this were a set. And instead of this, we do insert, and here also we do insert, and we don't need to reverse. We don't even need this. And now while I path dot count I plus plus. After I have a good I would like to do next equals I plus 1 and do the same for this while path dot count next plus plus. Now I have a good I and a good next. What I want is answer is initially 0. I would compare both of these. If a bracket next is greater than a bracket I, okay, and there is a mistake here. In its case, they have to be in the A range. If I lower than n and next lower than n, only then do this. And after this, I equals next minus 1. Why next minus 1 and not equal to next? Because I is going to be incremented when our loop ends, and this is what is going to happen. And answer wrong, correct answer. But this thing seems like over engineered, and this should have been much simpler than this. The answer should have been much simpler to find. This seems too complicated for a very simple problem. It is in Q. It might even be wrong. Wrong. Okay. Okay. We have already spent 45 minutes, but I think I can get this right. Okay. What are we doing here? Because right now my main concern is not to get this right as fast as possible, because I already know that I haven't been able to get this right as fast as possible. Right now, the main concern is the learning thing, and I want to see the things that I'm playing with in this question, and that would be cool. I can remove this because right now we are playing. We are not in the specific problem solving mode. This thing will be on. Okay, so first we are taking in n, then we are creating an array of size of the same size, then we are taking in the input, and then we are creating map. And the whole reason for this part of the code, the whole thing for this part of the code, this thing finds the maximum decreasing subsequence in our array, the maximum decreasing subsequence in our array. And also this code has the ability to recreate a path because of the history variable, which is this history. This stores that for the nth array, if I have shit, is I have made a mistake. Here I also have to initialize its string. Okay, that was bad. Yep. Maybe that is the thing that got us the wrong answer in test case 2 because history was not initialized, so it defaulted to going to 0, and that is bad if our maximum subsequence is not starting at the first element. And now let's go through the code once, and then I will submit this thing with my little change here. So after taking in the input, I have created a map variable y, a map of integers which stores two pairs. The key is an integer, and this integer represents the value ai at some point. And whenever I am at some index, I would like to go to all the elements which are either equal to or greater than this current element in the past on the left side of the array. And shit, this might be inversed, right? Yes, this is inversed on the left side of the array. And in that pair, this number, the first number, stores the length of the subsequence, the best length of the subsequence for this number. And the second one stores the index of this number so that if I want, I can go and access its history. And history stores for ith number, if there is a subsequence, the last uh, before adding this current number, what would be the index of the last number that I want to add to make this a subsequence. And it could be a index that is smaller than this, or a index that is equal to the current number, in which case there is no number to the left of this current number that is bigger than this number, bigger than or equal to this number. And mxi stores this thing in global sense. And then I start iterating from the second element. I get a iterator lower bound to ai, which returns me the number which returns me the number, the smallest number that is either equal to or bigger than the number ai which I have provided. And then I check if it is not equal to the end. If it is equal to the end, then I have no such number. But if it is not, then I do have such numbers. And if they are, then I start with this. My history would just start from the current element that I am at, and the current maximum is going to be just this one number that I am currently at. And while it is not equal to map end, that is, while I can increment this thing, while there are still subsequences which I can check, I would see if the second first. And okay, this might be a bit confusing because this second means the value, this thing gives the value in the map iterator, and in that value we are accessing the first element, which is the number itself, which is the count of the subsequence. And I add one to it, and then I see is it equal to the current maximum, and if it is, then update the current maximum and update the history for this current number, and then go to the next number. And when I come out of the while loop and I have the current maximum, I compare it with the global maximum, and if that is, then I update the global variables and I mpai. Okay, this should be outside. This should actually be outside. Yep, this should be outside. Okay, was that one of the problems? Okay, this should be outside. And after I have a good path, I create a set of indexes which has the indexes of the maximum of the numbers which are a part of the maximum decreasing subsequence. Decrease, not strictly decreasing, but just decreasing, non-increasing. And I start at mxi, and we keep going back, right? I becomes history of I, and we will keep doing this while history of I is not equal to I. That is, whenever we find index from which there is no history. And if that is the case, then we go out and we add this last number also into our path, and then we start with answer equals 1, and we find the number of pairs which are wrong. I I don't know. This might work, this might not work, which is the expected case, but I think we might get a time limit exceeded error or wrong answer. Okay, wrong answer. I don't know why we would get a wrong answer. We can look at this. Look at the place where we got the wrong answer. Okay. Okay, why is everything very close to 0? In the 55th, how would I know the 55th case? Okay, anyways, this approach is very bad. This approach, I think the idea that I need to find the maximum decreasing subsequence is good, but the implementation is wrong. Implementation could be improved, and for which we will look at the tutorial, which is not bad. Looking at the tutorial is not bad, it is fine, because the main goal right now is learning new things. Why would I consider a greedy approach? Grouping increases. Consider a greedy approach. There are two solutions. This is the thing that we went for, dynamic programming. Okay, what would be the greedy approach? Consider the following approach. We start with empty arrays B and C, then insert elements of array A one by one to the back of B or C. Okay, let's not read any further. We have something like this, and we would be adding elements to B or C. Does that make sense? That might actually make sense. We have something like this. We begin with this, and then right, we start at this thing, and we have our array B and our array C, and we can add the first number anywhere, does not matter, but from the second number. We will compare this with this. Right, we will compare, maybe does not actually matter. I think adding this to C would not be bad. Let's say I add this to B, because the first element in B is smaller than this thing. If it were greater, I would add it to C. And then in here, the third element, it is greater than 2, so I add it here. Then 1 is smaller than both of them. I think I should add it to the bigger sequence, to the longer sequence, which is this in this case. So I will add it here, and then 1, I do the same thing again, and then 7, which is greater than this, add greater than this. I would like to add it to the sequence that is smaller in size, or smaller in the sense that it has lower number of wrong pairs. And then 4, I can add it here, which is no problem. And 3 comes here, and the answer would be this pair, which is 1. Okay. Greedy approach. Maybe we can try to implement this thing. I don't even get the concept, by the way. We should do a little bit more reading. Okay. Our penalty function only depends on adjacent elements. So at any point in time, we only care about the value of the last element of arrays B and C. Suppose we already inserted this many into B and C. We now want to insert AI. Let X and Y be the last elements of B and C respectively. If they are empty, use infinity. Okay, okay, use infinity. Note that swapping arrays B and C does not matter. Yes, they are arbitrary in that sense. So without loss of generality, assume X lower than equal to Y. Okay, we will use the following greedy approach. If AI is smaller than X, insert AI to the back of the array with a smaller last element. With a smaller last element. Okay, with the smaller last elements because the difference would be lower. Okay, if Y is smaller than AI, then insert AI to the back of the array with the smaller last element. Okay, if AI is greater than both, that I think makes sense. Why that would work? Why would it work? Because it will give me more room to add more elements at a place where the last element was smaller. Okay, if X lower than AI, if it is between the two, then insert at the back of Y with the bigger last element. Yes, at the back of Y. Okay, the proof of why the greedy approach is optimal given below. If AI is lower than both, in this case AI is not greater than the last elements on the of both the arrays. So inserting AI to the back of either array will not add additional penalties. However, it is better to insert AI into the array with a smaller last element so that in the future we can insert a wider range of values into the new array without additional penalty. However, it is better to insert AI into the array with the smaller last element so that in the future we can insert a wider range of values into the new arrays without additional penalties. And by the new array, they mean the array in which we were not able to add the element. We didn't add the element because it still has a bigger value of Y. Okay, but if it is greater than both, then also add it to the smaller element because it gives us wide range of varieties. In this case, AI is greater than the last element of both the arrays, so inserting AI at the back to the back of either array will contribute to one additional penalty. However, it is better to insert AI into the array with a smaller last element so that in future we can insert a wider range of values into the new array without additional penalty. Makes sense. If it is in between, then add it at the back of Y. In this case, if we insert AI at the back of the array with the larger last element, there will be no additional penalty. However, if we insert AI to the back of the array with the smaller last element, there will be an additional penalty of 1. The former option is always better than the later. This is because if we consider making the same choices for the remaining elements ai plus 1 to n, in both scenarios, there will be at most one time. Okay, there will be an additional penalty. The former option is always better than the later. This is because if we consider making the same choices for remaining ai to an elements, the remaining elements in both scenarios, there will be at most one time where the former scenario will add one penalty more than the later scenario, as the former scenario has a smaller last element after inserting AI. Okay, okay. After this happens, the back of the arrays in both scenarios will become the same, and hence the former case will never be less optimal. Following the greedy approach for all three cases will result in the correct solution that runs in O of n time. Okay, let's try to implement this thing now. And it has been more than an hour on this single question, but that is cool because we are learning, right? That is cool. Mm, well, I guess first of all, do not call me sir. That is too much. The question is asking me to use AI. No, no, not yet. And for DSA, if you are starting DSA, then instead of learning algorithms and data structures, more important, the thing that is more important would be to get problem solving skills. And in which case you can do, if you know basic programming, right? You said that you know basic programming, then I would say you go to some website like this, Advent of Code, where you see some problem and then submit your solution, output the answer. Because the format of this website is very amazing, and this helps you build problem solving skills, which is very important. Because if you do not like solving problems, then you will drop off and you will not study DSA. So it is much more important to generate problem solving skills and kind of like a passion in that sense. And how much time does it take to get to intermediate level in CPP? Depends on the time that you are giving it, like the density of time. If you are only studying 1 hour a day, then it might take you a year. But if you are studying for longer, then it might be a month. And I think a month is fine. A month is fine if you are studying regularly. A month is pretty cool. A month is enough. And by intermediate, I don't know what you mean by intermediate. Whether you mean average or above average. Okay. VIA, B and C, and then I think I don't even need to create two vectors. I can just take their last element. But let's say we go with this. I less than n and I plus plus. Answer equals 0 and in B equals B comma C and B equals C equals int max, and if AI greater than B and AI greater than C. If AI is greater than both, greater, like strictly greater, and then it would depend on which one is smaller. Then let's always choose B to be smaller than C, right? B would always be smaller than C. That would help us. Int mn equals minimum B C. Okay. If C is greater than B, if C is smaller than B, then swap B comma C. Now here, if AI is uh, greater than both, then B equals AI. If greater than both, and answer plus plus. Else, if AI is only greater than B, then B equals AI and no increase in answer. And else if it is smaller than both, would that be the only case? If it is greater than or even equal to VI, then do this. And right, so I know that it is not greater than both. And here, if it is greater than, at least greater than or equal to b, and if even that is not the case, then it is smaller than both. Then it is smaller than both. Then add it to b. B equals ai, and I messed up a little bit. Here it should be c. It should be c, and here I would know that it is, if it is strictly, yeah, if it is strictly greater than b. C. Okay, that is correct answer. But why? Why? Okay. We start with B and C, and our answer is 0. And then we start iterating in our given array, which we don't even have to store. And we start iterating with our given array, and we make sure that B is smaller than C by checking if C is at any point. If it is smaller than B, then swap B and C, so that B becomes smaller and C becomes greater. And this would only happen when C is strictly smaller than B. If they are equal, then it does not matter. If AI, the current element, is greater than both, for which I only have to check. It's greater than C, then it is going to be greater than both. Then I can do this. B becomes new AI. Answer is incremented by 1. Else if AI is greater than B, at this point I would know that it is either equal to C or lower than C. But if it is also greater than B, then it is in the mid-between range, and then I would like to replace it with C, and my answer does not increase. Otherwise, B equals AI. That is when it is smaller than both. Then I would like to put it at the smaller, at the end of the array, which has a smaller element. And then output answer. That does work, but shit. Okay, I would like to review this question later. This took more than an hour, and I don't even know if it will work correctly now. It seems to be running. Okay, and accepted. That is fine. 1 hour and 12 minutes. That is a long time. That is a long time. 1 hour and 12 minutes with editorial. With editorial help. Okay, I can add this question in review. And yeah, in the question, how much time did it take you to learn this stuff? Okay, what IDL are you using? That is freaking cool. Yep, this thing is very cool. This is Vim. I'm using Vim in terminal. And how much time it took me? I have been trying to learn programming for about 2 years at this point. And yeah, but now I'm very serious about programming. So now I am streaming New Vim. Yep, New Vim is very cool. Very, very cool. Like, yeah, let me show you something. This thing, I can do all of this. This is not New Vim, this is Tmux, but I can do something like this. Let's say I want to find, I want to implement sieve of Eratosthenes. Then I can do here, look at the bottom here. I can write sieve and press enter. The whole thing is here. The whole function to implement sieve for SPF and finding primes is here. And how is this possible? Because you can configure Vim. I have all of this code here. I can write a code to find solution to a diaphantine equation, which we wrote yesterday in yesterday's stream. Yeah. The control that NewVim provides is amazing. Like with all of this stuff, NewVim is cool. We add this problem to review. Review. Yep, and now I'll restart the timer and go to the next problem, which is this one. Jumping through segments. Yep, that is cool. And there is one thing. Shit, I forgot. SL. Yeah, this thing. This is just a program which runs a train through your screen. If you press Control S, yeah, if you press Control S, it stops. And if you press Control C, it starts. It is just that. SL. And you cannot stop this program. This train has to reach the other end, and that is the only way to stop this program. That is just some fun thing. And now here, the next question. I'll drink some water and get to it. Let's go here. Jumping through segments, and I can put this thing up. Okay. The minimum integer with which it is possible to complete k. So the immediate thought that comes to my mind is binary search on a function for which lower values of k would give false and higher values of k would give true. And I simply have to find the first value that gives a true. But implementing that function, which takes in a value of k and a list like this, is crazy. Therefore, I need minimum. I start with 0. So for here, okay. Okay, I can start with 0. Shit, I thought I had focus on. Okay, cool. And that is even cooler. Shit. Okay. And now I will have a bunch of stuff. Okay. Min k equals 0 and for int I equals 0 I less than n I plus plus int l and r c in l r, and I need to okay, and also the last place that I was at, and I need to get to this range. Now if I'm already here, then cool. If last lower than L, then okay, and I will have to see if I can reach this place with my current value of k. Else, if is last is to the right of R greater, then I would also have to see. Now, if L minus last greater than k, yes, greater than k, then k equals L minus last. Uh, and here, if last minus R greater than k, then k equals last minus R. Okay, but if I'm within a subsequence already and I do not have to use my k, then I would like to use my k to go as far as I can at a place which is closer to the next one. Okay, that makes sense. In this case, last will be R. Okay, it would depend on R. Okay, last has to be as close to the next. Therefore, vector pair till segments first into x I bar second, and where L equal 6 I dot first and R equals 6 I dot second. And now I need a fancy way. Yep. Else I need to check on with the next one. C equals, and now if not C, then if not C, and I lower than n minus 1, then if seg I plus 1 dot first greater than last, then I would write it is greater than last. Okay, then last equals minimum of last plus k, or seg I plus 1 dot second, else if seg I plus 1 dot second, which is the right index, if that is lower than last, then last equals last equals maximum of last minus k seg I plus 1 dot first, if else if I'm already there, then cool, no problem. And at the end, wrong answer. I said 3, 7, 10, and okay. So my claim is I would be able to reach this with 3. Okay, given this thing, since I start with 0, I have to go to 1 at least. So therefore, k is 1 here. Shit. Okay, shit. Okay. Makes sense. That makes sense. Minimum till now, and should binary search would be better. Thank you. Binary search would be better. Not easier. I don't know how I can implement binary search here. But my brain feels like I should implement binary search here. Left, right, left, right, left, right. Given a single key, how do I test? Because I can make any move from 1 to k. Right? After my first move, I must be inside this segment, included, right? And the moves that I can make is cannot be greater than k. K is the maximum, but I would not always like to make the maximum move because I have to see things in the future. Shit, okay, I would like to see things in the future. But why did I output 3 here? 3 is like completely wrong. My answer was 3. In this one, answer was 3. It, which is completely wrong. Because I need 1 to get to this thing, and then I would need 2 to get to this thing. Makes sense. And then I would, yes, then to get to 5, I would need, yeah, I would go there with 2. 2 is sufficient to get there, and then 3 to get here, right? And then 3 to get here. But then for this one, it is messed up. I should have incremented because my last, which is 8 here, my last has to be smaller. Shit. This is completely wrong. 3 is not even the correct answer. Even with the algorithm that I am trying to implement, 3 should not be the output. So when I am at the last place, last, uh, okay, last is initially 0. That makes sense, right? That makes sense. And then we start iterating. We take the current left and right where we want to get, and C is false. That is, we have not made any change to the last thing. And yes, and if with that is completely wrong. Shit, that is completely wrong. If last lower than L, that is I'm on the right, then I would like to go to the, if I'm on the left, I would like to go to the right. And when I am then seeing how much to the right I need to go, and accordingly I am updating my K. This thing, I don't know. Yeah, this should not even be here. If last greater than R, then do this. Can I get, can I get to R using this? Yeah, using this K, can I get to R? Now it should still be wrong, but yeah, at least I'm not seeing 7 there. Yeah, I'm not seeing 3 there, which is cooler. And this makes sense. My answer is greater than what the current correct answer is. That makes sense. But why is my answer lower? Lower should not be the answer. Okay, here I need 10. Like I definitely need 10. And then I see that I need to go back, and using the thing I can go till 5. And then I would like to go to 15. So just going till 5 would be cool. And then I can go to 15, which would be cool. And from 15, I have to get back to 2, which would take 13, and 13 should be the answer. Why do I say 10? Because this, if not C, and I am not at the second last one, then I need to make my choice optimized. I need to make my choice option optimized. Here, 3. Yeah, grid is not going to work. And I think I've done a question like this before. And that question was written by Mr. Gennady Korotkovich. Okay, feels like I am doing 1400 level questions. This is good. Any ideas? Rating of question 1400. And again, thank you for this. 10, 20, 0, 1. Okay, this implementation is wrong. And here I'm checking for C, and which should be false when I am at the last place. It should be false, and I'm not at the second last one, right? Yes, I am just here, right? I'm just here, and yes, I'm just here. So this is not the second last one. I can go to the next one, 6, I plus 1, which would return 15 and 17. And I check with 15. Is 15 greater than last? That is, after making this move, would I have to go to last, to the right? And if that is the case, then I would like to be as right as I can, for which I see minimum last plus k, which is 20, and the segs of the second, the right limit of the second one, which I would like to go to next. But this is completely wrong. I cannot. I have to at least be in the current last one. Shit, this is completely wrong. This should be R, simply R. Okay, and after okay, would this work? Even if I'm on the right, even if I'm on the left, this is as right as I can go. This is as right as I can go. Okay, cool. Yes, because I cannot exceed R. That is one thing, and this is the maximum I can go without exceeding R. And then else, if the next one is on the left and that I would like to move to the left, then I will see how far I can go. I can go last minus k segments to the left, but I cannot go farther than the limit, which is L. So this should also be replaced by L. And at least we should get the correct answer for the last one. That is cool. For this one, yes, it would require some optimizations. For this, the answer should be 3. But then for this, we we can make it 7, and 7 would suffice. Wait, yeah, my uh, my program gives 7, but the answer is 5. Yes, it is. So whenever I am updating k, I have to be smart about it and not just take the best right now. And this is very similar to the monster problem that was written by Mr. Gennady Korotkovich. And in the first place, I can use k equals 3, which is very, very fine. And then in the second place, I can use this, or I can I know the last one, and the only limit I have is I have to be inside the last thing, that is this thing. And if I went to this place from the left, the maximum I can have would be last minus this. Okay, I have to extend further. There is the option to go to the rightmost place and then choose 2, but minimizing this jump would mean maximizing the initial jump to 8, which is even worse than my solution. Therefore, there has to be a middle point which is good for both, and that middle point, okay, if I were to visualize this thing, okay, at the start I am here at 0. This is 2D is fine. 2D is fine. At the start, I am here at 0. Then one segment is this from 3 till 8. And then the other segment is 10. This is 10, right? 10 till 12, 18, 10 till 18. And I have to make a jump. So if I only want to go to this segment right here, the minimum jump I can make is this, which is 3. K equals 3. But then after this, I have to get to this place at least. So I can make my K equal to this thing, or an alternative would be when I was making this jump, I can go till 5, and from that point, I can go till 5, 5 more. So I would suffice with K equals 5 instead of K being equal to 7. And I would like to see in which class of problems this problem comes, because then I can study this. Okay, so I need to choose the best value here. And so I need to place this point at a optimal position so that I do not increase this distance and I do not increase this distance more than they need to be increased. Right. And how do I make this the best choice? What I need is a way to get from this point to this point, and the best thing would be to take the middle point, or if the middle point is to the right of the right limit, let's say this 8 was here, then I would take 8 because I cannot go past 8. But this would all flip if this second segment were on the left. Everything would flip in that case. I would choose 3, and then from 3 I would go with minimum K. So I need to, whenever I'm considering a jump, I need to consider the two next things. What are the limits for n and k? N is 10 power 5, so that is fine. N is 10 power 5. Okay. So k. So whenever I am traversing, I need to know my current place where I currently am, and also the place that comes next. Uh, so that my current choice takes care of the next two choices. But then I could present the same argument for the whole of the array. Shit, which is bad, which is bad. Shit. Okay, questions are getting harder. And under which domain does this question comes? Is it a graph question or a general numbers question? Okay, I need some optimization. This seems like dynamic programming somehow. No, it doesn't. It seems like I have to write a function that would take a key and return to me whether it is possible to go from which I can do, which I shouldn't. Should, okay, shit. Okay, yes, binary search. Binary search. Okay. Binary search is the thing that I have to do. Okay, makes sense. And then CNN and then VIAN for auto XA CNX, and then binary search int L starts at K equals 0 and R starts at, what is the maximum value of K? 10 power 6. The maximum value for K would be either the, okay, they are always positive, so 10 power 9 at max, 10 power 9, and in which case I would like to change these to long, which is cool. Vector long, and R would be cons long, range equals 1e 9 and 7. This equals range, that is the maximum value of K. I would not never need a better value of K. And now I would have to write a function which would return bool and is correct if this will take in a K and my vector of long reference A, and this will return something. And okay, then while L lower than R, lower than equal to R, int answer equals, int answer equals this, and long K equals L plus R minus L divided by 2. And if it is correct, if is correct, this K with A, if it is correct, I need the smallest correct. So equals K and answer equals R, which is just equal to K. Else L equals K minus 1 and L equals K plus 1. That is wrong. Right. And now I believe I can return K. What is it? Answer. But before that, I have to implement this function for a given K. And okay, I'm stupid. Okay. Shit, this is wrong. It is not a vector. This is a pair of long numbers, very long numbers, and right. And if this is not how you take it in, n equals I less than n I plus plus, and Cn AI dot first into Cn AI dot second, and change the function definition here. Pair long. Yep, that works. And now the implementation for this function is correct. For a given key, right? I will begin with a range, which will tell me how far I can go. Okay, int L equals 0. Currently, I can go to 0, and R equals K. Uh, for auto X in A, now to make sure, if X dot first, which is going to be lower than the other thing, which is going to be lower than X dot second. If X dot first is lower than R, if X dot first is lower than R, why am I even checking that? If that is the case, yep. Okay, I have to take intersection of these two. Okay, left equals maximum. Left equals maximum of the current, either the current left or X dot first, which is wrong. Which is wrong, which is wrong. There is my range. I can go there, take the maximum. If it is on the left, then also take the maximum, which is very cool. And R becomes equal to minimum R or X dot second. R becomes equal to the minimum R or X second. I'm taking intersection. L becomes the maximum and R becomes the minimum. Right. And then after updating, if R is lower than L, return false. Okay. Okay, binary search. Binary search. Wrong answer. That is very cool. Four. Okay. Mhm. Okay. That does not make sense. Okay. That is completely wrong. L plus R minus L divided by 2. That is K. R equals K minus 1. And if it is true, then do that. Right. So is it not being true at any point? Let's see. C out is correct for K equals 5, let's say, and pass in A. Okay. 5. How many of them are good with 5? This will be wrong. Okay, this should have returned true. And so let's see with 6. Is it wrong? It should now. Okay, this one is still wrong for even for 6, which is wrong. It should have been 1 for a given value of k. It should have been 1 for k equals 6. It should have been true. For k equals 6, this thing should have been true. Yep. Even for k equals 5. For k equals 5, my left limit would be 3 and my right limit would be 5. So I'm in 3 and 5. And when I see 10, my left limit would be 10 and my right limit would also be makes sense, right? I'm not simply taking their intersection. Makes sense because I can jump if I have the ability to jump. Yes, makes sense. And wherever I land, okay, shit. Okay, yes, this is wrong. My implementation of is correct function is wrong. How to determine for a given value of k if that k is correct or not. Can I just go to the next segment? If yes, then okay. If I cannot, then false. But how do I determine if I can go to the next segment? I will have a range. Yes, I will have a range. Okay, after updating, if I do not return false, that means I am somewhere from left to right. And given that my range is pretty cool now, my range on the left would be left equals minimum maximum of either 0 because I cannot go left to the 0 or L minus K. 0 is long down. Because I could be anywhere from left to right, then my left range is this and my right range would be to the right of right, which is R plus K. R plus K. Now does it return true for 5? Now it does return true for 5 and for 4 it should return 0. Cool, cool. Uh, okay, binary search we go. Binary search we go. That binary search was the first thing that came to my mind when I read this question. Okay, is it going to work? Yes, it is going to work. It is going to work. It is going to work. Yes, it is going to work because I am updating answer every time to be equal to the new better value of k, and feels like this question should not have taken 42 minutes because I already knew about binary search. That is bad. This should not have taken me 42 minutes. Very bad. If this is correct, that is, if I get this, I do get this. Okay, 44 minutes, let's say. 44 minutes, and I can guarantee that when I look at the tags for this thing, I will see binary search. Binary search. Yes, because this does use binary search. Uh, And the time complexity would be uh, to find out if a certain k is correct or not. It takes n time to go through each segment, and binary search itself takes log n time. So the total time complexity would be n log n, which is very cool, which is fine when your n is 10 to the power 5. Because log of 10 to the power 5, what is log of 10 to the power 5? Log, um, not with 10, log with 2 divided by log 2, 16, 10 to the power 16.6. That is very, very fine. D. Should idea came from this guy, and you can see his name is black because he works at Code Forces, and he has not solved a single question, and he has been at Code Forces for, I think, 16 years, if I am not wrong. 16 years, yes. Yes, and he's just a guy. Not a single question solved ever. He just works at Code Forces, from Code Forces headquarters. Cool. And now this thing. First, let's note that if we can pass a level with some value of k, then we can make all the same moves and pass it with a larger value. This allows us to use binary search for the answer. Shit. I could have done this better. I could have done this one faster. To check whether it is possible to pass the level with a certain key, we will maintain a segment in which we can find ourselves. After each move, it expands by k in both directions to reduce the intersection with the segment where the player must be at. No, it cannot expand in both k in both directions and is reduced to the intersection with the segment. That makes more sense. That makes more sense. So, but what I am doing is first I'm reducing and then expanding by k. The same thing in reverse in both directions and reduced to the intersection with the segment where the k player must be at the move. And how do you take intersection? You take the maximum value of L and the minimum value of R from both the things, right? And if R is lower than L, then you do not have an intersection. That is cool. That is cool. That is cool. And what can I take from this question? I can take from this question, if you feel like binary search is the way to go, then to implement a binary search. That is what I can take from this question. Remove this. Yep. Rating of questions 1400. 1400. And now I would like to move on to the next question. We have done 3 questions till this point, which is cool. Which is cool. How long has it been? It has been 2 hours and 38 minutes, which is fine. I would like to do 5 questions in total, at least 5 if I could. That would be nice. So binary search. Shit, I should have been able to do that one. Binary search. Binary search. Binary search is right here. I did read about binary search. Here, binary search in the CPHB Competitive Programmers Handbook. Yep, binary search for something like this thing. Yep, this is the exact same thing. For some lower values of k, and the answer is false. But for larger values it is true, and we are looking for the value of k that is true, the smallest value of k that is true. This is the exact thing, finding the smallest solution. This is the exact question that we did just now. So I should have been able to do this by NT Laksonen. Okay, and now moving on to the next question. This is and cool. Minimum value of k after performing k operations. Okay, this is cool. If k is greater than 2, that is the thing. And how do I calculate the value? Okay, 0. Yes. If k is greater than 3, then answer would be 0. If k is greater than 2, then answer would be 0 always. Here, answer is 0. But if it is smaller, if it is smaller, then I would have to see. If it is 1 and 2, if it is 1, then we would have to see. And if it is 2, those are the two edge cases that we have to consider. Otherwise, if k is greater than 2, then the answer is always 0. Because you can just choose. Okay, maybe not. Shit. Okay, because of this condition. Shit. Okay, okay. This thing. You cannot always make 0. Yes, shit. Okay, shit. I is to the left of J. And find the minimum. Okay, if k equals 1, then greedy. If k equals 2, then non-greedy. If k equals 3, then also non-greedy. Okay. N and k. And let me do int is long, right? And vector of integer for Right. Mm, Now all the values where I is smaller than value of A and sort them, find the minimum difference, use that if k equals 1. Right. Indexes I less than n I plus plus, and now if A I strict k strictly uh, greater than equal to I, then n dot push back I, and then if k equals 1, then a greedy approach where I choose the minimum distance right now, and that would be my answer. And also I would like mn equal minimum mn ai, and if minimum is already 0, I cannot hope for anything good, better. If mn, if not mn, then C out is 0, right? Else we would have to say if k equals 1, then sort the thing. If k equals 2, then I would like to find a number that is find a difference that is as close to the last number as possible to find a smaller. uh, Not as close to the last number. I would have to, first of all, to leverage that, I would have to make sure that it is greater than n, its value is greater than n, the length of the array, so that I can choose it. Otherwise, if I cannot, then what is the point? And if I can do that, then I will do the operation a second time. And in the second time, when I'm doing the operation, the second time when I'm doing the operation, I can add this to my set. I will create a set of all the indices that I can choose instead of making it a vector. Uh, yep. Insert insert and I will see the smallest distance right now. Like I can go through the set and see the smallest distance, which I would have to do in k equals 1 and also in k equals 2 and also in k equals 3. The smallest, yes, the smallest right now. Shit, there is a restriction to the value that I can add. And the restriction is the difference. There is a maximum value and there is a minimum value that I could choose. And I could choose the maximum value twice. But for k equals to 1, I need to find the minimum difference. And the shit, the thing does not have the values. Shit. Uh, this thing has indices. And why would I like to sort indices? That is so wrong. Yeah. Now available. The numbers which are available for choosing are in my set, and I can just go through them and find the minimum difference. And MND, minimum difference, is max at the start, and for auto x, I will dot begin while x is not equals, I will dot end and x plus plus, and a minimum difference equals. I need to access the next number. Okay, that makes sense. But to do that, I would need a custom loop. Auto x equals avail dot begin and while x not equal avail dot end. What I will do is auto next is equal to x and next plus plus. I have the next number. I have the current number. What if I am at the end? Yes, makes sense. Makes sense. What if I am at the end? And if I am at the end, I would not like to go there. Therefore, using a set is absolutely wrong because this is a set. Okay, shit. Okay, using a set is bad. Vector of int, avail, push back, and here, or maybe in any case, sort avail dot begin and avail dot end. After that, if k equals 1, then I need to find the minimum right now, minimum difference right now, and that would be very, very cool after sorting for int I equals I less than n minus 1. I don't want to go to the last element and I plus plus and MND, minimum difference, equals minimum of the current difference, which is going to be avail L I plus 1 next one minus the current one avail L I, yes, that is going to be the minimum difference, but there is something wrong with this. Do you? Of course, there is something wrong with this because it has only one argument, and when I am outside, I will return the minimum value. Okay. In this case, answer would be minimum of MND or MN, right? Minimum of MND or MN, and then new line. At least my and then return. Now, if k equals 2, then the best thing I could do is take the differences, and after I take the differences, if the minimum difference is equal to 0, then that is the thing that I should achieve for. But if the maximum difference is bigger than the size of the array, then I can choose that twice, and then at the end I cannot choose those last two elements. Okay, so this is not really good. So I need the first two numbers that I choose should have a difference which is very close to one of the numbers that I can choose. But okay, I will have two things. When I traverse, I will find the minimum difference. Right now it might be 0 or it might not be, and also I will find the best choice, the best possible choice where n is greater than that. Okay, if k equals 2, then int m and b, the same thing, the exact same thing I did here. Maybe that is an indication that I try, do not repeat yourself. Again, yeah, shit, that thing was already removed. Okay, and if k equals 1, okay, I do not like the fact that I am doing this thing again and again. I can remove this. Yes, remove this from here, and if 1, then this. Otherwise, this. But that makes sense now. I would have to go through the thing again, but I can optimize now. If MND is not MND, if it is not 0, if it is 0, then see out the same thing, this thing. Now, if k equals 1, then whatever is the minimum, then I'll put the minimum. Otherwise, also see the possible differences that I could choose. Okay. For int I equals 0, I less than n, I plus plus, or I less than n minus 1, I less than n, I plus plus. And now the possibilities, okay. N, the new size, the new element is going to come at the index n plus 1. And this has to be strictly greater, not greater than or equal to, because this is 0 indexed. Yep, because this is 0 indexed. Now, if k equals 2, minimum difference, and I would like to go through all the differences, which is crazy shit. Can I use 2 pointers here? In 19 minutes, since the difference is always increasing, if I move my right pointer to the left, the difference would decrease. If I move my left pointer to the right, the difference would still degrees. But if the maximum, yes, I'm not looking for the maximum, right? Because I only have two choices. So in the second choice, to make this possible, I would want my difference to be greater than that. Okay, I can use two. I can use two pointers, both starting from the start. No, that would not be a good implementation. Using two pointers. Shit. It's been 3 hours. Okay, that is cool. Fine. I know that my solution is correct for k equals 1. Something like this, I will get the right answer, which is this. Right, let's test that. Or I might get segmentation fault, which is messed up. Okay, I'm doing avail. Okay, that makes sense. Avail dot site, available dot site. Again, seg fault. Okay, and available dot pushback. Okay, that makes sense. And I get something totally wrong. By the way, that is the maximum value for an integer that you can store in an integer. For k equals to 1, minimum or mnd integer, but integer is a long. Int 64 max. So for this, I should see this thing, which I do not. I still do not. Okay. Sort, do something, and if k equal to 1. Okay, into max here. Okay, makes sense. Now, at least here, I should see this number, which I do. So for int k equals to 1, the implementation is correct. But now for k equals to 2, okay, I can go up to n square. I can go up to n square, which is very cool. I can go up to n square, which is cool. Okay, so for I will have a bunch of distances. I will have a bunch of distances. I can go through them, and there will be a one that I would choose. Okay, I can go through this and add it in a set and see how much closer this current distance is to some other distance. Go through this, and this is using a lot of memory. memory that I shouldn't be using. Okay. This and for int j equals I plus 1, which does not feel very good, while j lower than n j plus plus, and make this lower than n minus 1, and this is wrong, this is wrong, this is correct. This dot, i- if there is no distance, if there is no distance that is greater than that, I would like to choose that. No, just insert. This dot insert the current distance, which is avail I plus 1 minus avail I. And when I'm done with that, now comes n square, n minus 1, I plus plus, for int j equals 0, I plus 1, I plus 1, j lower than n, and j plus plus. Now, if shit, that is so wrong. That is so wrong. What was I thinking? Okay, now okay, shit. I do not need this. I need to make its value as close as possible to some of the other values that I could choose later. Right. That I could choose later. Int diff is int 64 max. And now if a avail dot size, because we are traversing in available. If available dot available I available j, which is greater than available I, minus available I, if that thing is greater than, what is the minimum difference that I can add? The length would become n plus 1. If this is greater than n, then I can choose this. That is cool. If this is greater than n, then look for best fit, which would be lower bound. So auto best is lower bound on available dot begin and available dot end for which value? Available j minus available I. Yeah, available j minus available I, that would be the best value, and I think this is not an integer, it is an iterator. Okay, after I have that, then if they are equal, then cool. Right, either I stick, no, I do not stick. Now where is my current value? Right, okay. Instead of lower bound, upper bound would be better. Now I know for a fact that the value that best is, it is greater than my difference, which is cool. So I can take the minimum of the two. And int mn2 diff, very strange naming convention. Uh, Also best if best isn't equal to avail dot end, I need to subtract from best. I would like to subtract from best and from the value that is before best. So let's say int c min, current minimum, nothing. Current minimum is nothing. And if this is not, then current minimum is going to be equal to best, or go to best minus available j minus available I, which makes this plus, and which is end c equal available j minus available I. C and right, because I know for a fact that best is greater than C. Right. And if that is the case, now if C min isn't equal to -1, then and also, okay, now there might be a number to the left or not, which I can check if best isn't equal to available dot start. Now I know that I can go to the left, and if I can go to the left, if C min is not equal to -1, then I would like to compare C min is going to be minimum of whatever the current value was with best minus minus, or minus minus best. Go there and I will not start. Begin. Uh, Absolute difference. This is going to be smaller. Yes. So my current value, which is C, minus go to minus minus best. I think there should be no problem if I remove this. Anyways, I will not remove that. C min minus minus, and rating of question 1400. First of all, do not call me sir, and second of all, that is Vim. I am using Vim, new Vim, and I will be right back. I have to go to washroom. Me back. Me so back. This thing. And where was I? Best. If best is not equal to the one, then I can compare it. Else, you mean just equals C minus go to minus minus best. That is cool. Okay, I was too deep into this thing. Okay, after this, I need to compare Cmin with diff. Diff equals minimum of diff and current minimum. Does this make sense? Yes, this does make sense for all possible values of the possible new element that I would add. I'm looking for the minimum difference that I could get, and that is cool. Then I can see out diff and return. Now I should get at least correct answer for k equals 2. Okay, else for any case, see out yet to be implemented. And okay, I say 5 for this, but the correct answer is 3. I say 5, but the correct answer is 3, which is correct. Minimum of m n comma minimum m n b and diff. Okay, 3 is also correct. Now for k e greater than that, or k greater than that, I have the flexibility to choose both the elements that I will be choosing at the end. Okay. Okay, that is one thing. If the new number I add a k. Okay, cool. If I can do that, then the difference would be 0 and we are good to go, which would be just the same thing. How great, how greater is k from diff, for which int mx new equals 0. Right, mx new equals 0 and c mx new equals maximum of c and mx maximum. Yes. Uh, yeah, just do that. Do not think about anything else. 27, yep, and 26. Okay, here we are, and now if k equals 2, then this is what you do, and return else if something else, if k is greater than that, Then I have the ability to do quite a few things. Choose the maximum difference if maximum difference is a lot bigger than k, if the maximum difference is greater than k and n plus 1. So if nu mx or mx nu greater than n plus 1, then cout 0. Else if that is not the case, then I would choose 1, and whatever I add, yes, otherwise cout minimum of mnd diff. That does give me the correct answer. It does not feel right. Does not feel right. I know my code till this point is correct, but till this point it is correct, but this last case, when I do not have any optimization, if I cannot choose the last two, at least I'm going to choose at least three IJ pairs, and if I do not have the ability to choose them optimally, then I would do the best with what I have got. If you cannot beat them, join them. Okay, let's see. 42 minutes. That is a very long time. It has been 3 hours and 21 minutes. And I'm struggling a lot with these questions. I would like to do from shit. Is it wrong? It is wrong. It is like literally not wrong. Not even TLE. It is just wrong. Okay, what is the basic thing in this question? The operations that have been provided. I can choose and add new numbers. This is the restriction for choosing numbers. This is the number that I'm going to add at k. And I have to do k operations. If k equals 1, if I can only do 1, is k is at least 1. If What if k is very, very big? The maximum, minimum, uh, difference above and no, I already had that. I already had that. Ah, shit. Wrong, wrong, plain wrong. And this is just the fourth question. Okay. Okay, what I can do is, since it does not seem like it is very helpful to just try to do these questions like this in one go. What I should do beginning from now onwards is instead of solving CP31, I think a better thing would be like I would be solving CP31, but on my own at my home without streaming because struggling. I do not want to explain things that I'm seeing for the first time. Therefore, much better thing to do on streams from now on would be CACS. And right now I am practicing graphs and I would like to do all of these graph problems. And it would be crazy because I can just, after I solve a problem, I can go there and do some deliberate practice. After solving a problem, I can go to the competitive programmer's handbook and read something about graphs, whichever whichever thing was used in the last problem, and then read about it, do a few questions, read about it, and do a few questions, and that is going to be the thing. So for now, this is going to be it. And today I was able to do 3 questions only, and it took me 3.5 hours to do just that much. But yeah, we are making progress, and that is cool. And that would be the end of today's stream. And